Hi, I'm Aaron Weed. I'm going to show you how I made this stand to hold this 950-pound mill. Before we get started, there's a few things I want to point out about why I designed this the way I did. One is that these extra long arms here aren't here just to accommodate these leveling feet and the casters, but they're also here to accommodate shelving that I will put in place on both sides that will hold the tools I need so they're right at the machine while I'm working on it. Another design consideration is the height of the stand. I used taller casters, not only because they hold more weight, but also because it brings this machine up to a more working level. The first step is to glue up a bunch of wood. Using several laminations of wood instead of a solid piece will provide for more stability. And this is because the opposing wood grains help to counteract the wood's natural flexibility. Then the beams need to be flattened and squared. Here I'm cutting tenons on the two cross beams, which I have clamped together on this sled for efficiency. I then bore and chisel the holes to make mortises on the front and back beams. I'll use regular nuts and coupling nuts for the leveling mechanisms. The coupling nuts will provide enough threads to hold the weight of the machine. The regular nuts won't hold weight, but rather are used for a wrench to adjust the height. I cut the coupling nuts in half to bring them down to a more reasonable length. Here are the coupling nuts that have been split in half, and now they're at about the height of two regular nuts, but a lot better than if I didn't split them in half, which would have made them the height of about four regular nuts, and that just doesn't leave enough meat on the wood where the wood will rest on the nut. And this flat area that's right here also gives a good surface area where the wood is going to rest right on top of these nuts. Then I went on the bench grinder and I made these grooves here, and these are where the epoxy will fill in and prevent these nuts from falling out, if that were to ever happen. I drill the bottom holes where the coupling nuts will be mounted. Then drill the top recesses where the lock nuts will be placed. I'll show these later in the video. These top recesses will keep the threaded bar from sticking up too high. A washer on the top of the hole is used to provide compression support. Now I can make the holes that will go all the way through the beam. I made dados where the mortises are located so that the cross beams will fit into them for added support against any twisting action that may occur. I also made recesses for the casters to prevent the stand from being too tall. This 45-degree angle was added just for aesthetics. The tenons of the cross beams were made loose to accommodate epoxy. Epoxy needs to have some amount of mass for it to be effective. Squeezing out too much epoxy makes it lose its structural capability. This is thickened epoxy to help fill large gaps and maintain its shape. Then I used a semi-thickened epoxy to help it flow through the medium-sized gaps when the tenons are inserted. And lastly, I used normal thin epoxy to fill the smallest gaps. When I insert the tenon, I want to have outflow of epoxy to ensure all air gaps are removed. Excess epoxy is not a problem to clean off the wood. Any soaked-in residue will not affect the final finish. Then I repeat the same epoxy steps for the last beam. This time I used a brush to be faster. Once complete, I let it cure for another 24 hours. When mounting the coupling nuts, I didn't want epoxy to leak under the nuts when I poured it, so I used thickened epoxy on the ridge of the hole, then set the nut and let it cure. This created a seal to prevent leaks. Then I poured normally thin epoxy to fill around the nut. And I just used a torch to remove the air bubbles. The frame is complete and now gets 2 coats of epoxy for a finish that seals out the badness. I add the casters at this point. These are rated for 750 pounds each, and I got them for only $12 a piece. One thing to note about the size caster to get is to factor that a large amount of weight may only be on 2 of them at a time when rolling over an uneven surface. which is almost every surface. So it is best to get higher rated casters than you think you will need. I waxed all metal parts to prevent rust. These washers will provide compression protection to the wood from the locking nuts that I'll show later. A little bit of epoxy dripped down one of the nuts from my sloppiness, so I used a tap to clean it out. Now on to the leveling feet. For the feet, I made steel inserts that have recesses. These will keep the threaded rod from slipping off the feet and provide a durable surface that the rod can twist on. Then I made a flat dog point on the threaded rod. This dog point is what will fit in the recess of the steel insert. With all the threaded rods cut to length, I can now add the adjusting nuts. These nuts are what the wrench will be applied to for raising and lowering the stand. These nuts will not deal with vertical force, but rather will have lateral force applied to them. So they must be secured in place to prevent them from slipping. I do this by first applying Loctite to initially secure them exactly where I want them on the rod, which is just slightly above the dog point. You'll notice I pre-drilled a hole on one side of the nut before attaching them to the rod. This is to reduce heat when I drill through the rod later, since too much heat can actually loosen the Loctite. After 24 hours to cure the Loctite, I can now drill the holes where the roll pins will be inserted. I cut a piece of wood just as a jig which holds the rod perpendicular to the drill bit. These are the roll pins I'll use to keep the nuts from slipping when under force. They were too long, so I cut them down to size. The ends of the roll pins need to be tapered so they insert in the holes without any issue. I then press in the roll pins. This completes the threaded rod part of the assembly. Making of the actual feet consisted of another block of glued up wood. I cut off the corners to speed up the turning process. I could have just made them square, but I thought round would be a good look. I drilled a hole in the top of each foot for the steel inserts that I had made earlier. I also made a recess in the bottom of each foot so that only the outer edges provide support and would keep the feet from wobbling. I then applied 3 coats of epoxy to keep any moisture from seeping in the wood. In between coats is when I epoxied the inserts into place. With the mill mounted on the stand, we can roll it into its permanent place. With the mill in position, I can now start the process of leveling it. And so far, this frame is proving to be pretty stable. We'll see what happens though after I get it level. Before leveling, I'm going to start the lock nuts. The feet are preliminarily set just so that the casters are off the ground, and I'm going to use a machinist level to level this so that it's perfectly level. I'm setting up a gauge to ensure the level is placed in the exact same place each time I move it during adjustments. I know that leveling this with a rusty table won't be exactly as precise as it should be, but I have some projects I need to rough out with this mill before I start digging into refurbishing this mill. But later on I will eventually turn this mill back into a pristine condition. Now the many ups and downs of leveling, which I shortened up quite a bit in this video. Once it is level, I can tighten the lock nuts. These will prevent the stand from racking side to side and keep the adjustments from coming loose. So far, it is pretty stout. I set up an indicator gauge to get a real idea if the stand is stable. Pretty good for a stand to only have 3/1000ths of an inch give. For a homemade wooden stand holding 950 pounds, I think this turned out pretty good. I hope this video was of help. Thanks for watching.